Welcome back. This is the fifth and final video for Chapter 8, Writing Classes, and this is also the last video in the series for the Introduction to Programming Using Processing textbook.
Happy days are here again, the skies above are clear again. Let us sing the song of cheer again. Happy days are here again.
In this video, we'll wrap up our object-oriented programming coverage by talking about what advantages there are to using object-oriented programming, particularly when compared to an older style design like was used in our Chapter 6, where we did structured programming and top-down design. Almost all of the benefits that we're going to talk about flow from the fact that all of the data related to an entity is encapsulated inside a class. So we saw that twice in Chapter 8, first in the song class, which encapsulated all the pieces that were required for one song in our 4-song playing MP3 player, and then in our dude class that encapsulated all the things that were important about our virtual partygoers in the mosh pit example. In addition to the data, all the methods that are related to that data are also encapsulated inside a class. So the song objects knew how to draw themselves on the MP3 player's interface. The dude objects knew how to draw themselves, how to determine if they'd run into somebody, how to determine if they'd run into the walls, and so on. Now, because those things are all encapsulated inside the classes, that encapsulation hides a lot of the complexity of the code, which ends up simplifying the logic and code of the client programs that use those objects. So we saw that in particular when we compared the Chapter 4 MP3 player against the Chapter 8 MP3 player that used song classes. It really simplified our logic, and that's a huge benefit. Another benefit of encapsulation is that it can protect us from ourselves, and that will become particularly true in other languages like Java or C++ or C#, where we can provide access specifiers on fields and methods. Think back to the alarm clock example. We should interact with the alarm clock via its interface, that is, its buttons, rather than tearing it open and poking at its innards with a screwdriver. Many different classes are also very flexible, allowing us many ways to configure objects of those classes. This is typically done via a series of different constructors, allowing us to create objects that are just right for our application. It's sort of like going to a car dealership and ordering a car from the factory. You can get the base model, or you can put a series of options on the car in order to tailor it to your needs. Another benefit that's not strictly related to object-oriented programming, but that is enforced by Java and processing, is the idea of separating our programs into different classes and therefore different files helps to keep each piece of code relatively small. It also helps us to locate problems when we have them. So having our code grouped by its function in different files helps us to understand things better, helps us to maintain our programs more easily. Now, we've only scratched the surface of object-oriented programming. There's a lot more to learn, and that will typically be done in other programming classes. So let's talk a little bit about what's coming up with object-oriented programming. One of the major things will be true information hiding, where we can provide access specifiers to our fields and methods. That is, we'll be able to use a private keyword to make certain fields and methods completely invisible from the users of that object. And so that's sort of putting a lock on that alarm clock so that the case can't even be opened and you can't touch the insides. All you can do is interact with it via the public interface. Another very powerful concept in object-oriented programming is that of inheritance. And in inheritance, what we do is we can take a class which is almost but not quite exactly what we need, inherit all of its properties and methods, and then add or modify a few of our own to make it just right for our particular application. Related to inheritance, there's also the idea of abstract classes and polymorphism. So an abstract class would form the root of an inheritance hierarchy or a tree of different classes that are all related to each other. So think about the idea of an animal, which is generic, versus a dog or a cat or a cricket, which are all specific. Animal would be an abstract class, whereas dog, cat, or cricket would be concrete classes. Polymorphism deals with the methods that are defined in that inheritance hierarchy, and it dictates that the method that actually runs when you call it from an object is determined by that object's actual type. That's a lot more complicated of an idea, so we will not talk about that anymore here. We'll cover it in another class. Finally, there's also a concept of design patterns. And design patterns are canned, object-oriented designs that are applicable to many different types of applications. So if you're going to go be a software developer, eventually you should learn about design patterns so that you can design and implement software more efficiently. Well, that about wraps it up. Thanks for listening. See you later.